Hi, today we are doing the free response problem number 3A for Mac 2311 Engineering from the Spring 2011 Exam 1. So number 3 asks us to examine the function below and supply the requested information. So our function is f of x is equal to x squared plus 2x over x cubed minus 4x. Okay, and so what we're going to have to do is we're going to have to sketch the graph, and we're also going to have to find some limits. So first what we want to do is we can simplify our function here, and that's what we're going to do first, and it's going to make it a lot easier after that to graph it then. Okay, so what we can do is we can pull out an x from the top and the bottom. So we have x times x plus 2 all over x times x squared minus 4. Okay. And so we can simplify it even further, and so if we come down here, we still have x times x plus 2 on the top, but then on the bottom, this x squared minus 4, we can factor it out, and so it becomes x times x plus 2, x minus 2. Okay, and so now from here, we see that we have an x and an x on the bottom, and an x plus 2 and an x plus 2 on the top and the bottom. And so we can cancel those out. So if we cancel out the x with the one on the top and the bottom, then we know that there has to be a hole at x equals 0. And then also, we're going to cancel out the x plus 2 and the x plus 2, and so we know that there's going to be another hole at x equals negative 2. So now our function, we simplified it down to this. And so now this type of function we're very familiar with sketching, whereas before it was a little crazy looking. Now it's something that we can easily graph, right? Because we know that the graph of 1 over x just looks like something like this. So this is the graph of 1 over x, and so we have 1 over x minus 2. So we know that that minus 2 is just going to be shifting everything to the right by 2. So whereas 1 over x has a vertical asymptote at y equals 0, our vertical asymptote is going to be at 2 now. So we have a vertical asymptote here. And that's because x can't be equal to 2, because if it is, then our denominator is equal to 0, and then our function doesn't exist. And so now we know that our graph just looks something like this. Okay, and so we sketched the graph, and now what we have to do is we just need to find some limits. So I'm just going to erase the graph I made of 1 over x. And so our first limit that we need to evaluate is the limit as x approaches 2 from the left of our function f of x. Okay, and so we already graphed f of x, so we can just go and look at our graph and see what's happening. So we want to go to 2, which is right here, and we want to see what's happening as x is approaching 2 from the left, okay? So as x is approaching 2 from the left, we're approaching negative infinity. That's what our function is going to as it's approaching 2. So this is equal to negative infinity. And now we need to evaluate the limit as x approaches infinity of f of x. And again, we're just going to refer to our graph. So let's look. As x is approaching infinity, so the farther out we go on our x-axis, our function is just approaching 0, right? And so this limit is equal to 0. Another limit we need to evaluate is the limit as x approaches 0 of f of x. And so let's refer to our graph. So we are approaching something at 0, right? But we have to remember from earlier when we canceled out things in our function, so our graph is missing the fact that there should be a hole at x equals 0 and a hole at x equals 2. So let's add that into our graph right now. So we have a hole at x equals 0, and then a hole at x equals negative 2. Okay. And so the left and the right side of 0, they're both approaching something, but it's not actually equal to that there. But we can figure out what it is just by plugging in x equals 0 into our function. So it's equal to negative 1/2. And then the last limit we need to evaluate is the limit as x approaches negative 2. of our function. Okay, and so again, we have a hole in the graph, but it's approaching the same thing from the left and the right side. And so if we just go back to our function and plug in a -2, we get 1 over -4, and so our function is approaching -1/4. But our function, however, does not exist at that point. So although the limit is approaching it, it doesn't actually, f of -2 does not exist. Okay, and so 3a is asking us just a few more things. So it says, what feature does the graph of f of x have at x equals -2? So we already wrote that up here. There's a hole at x equals -2. And we can see that on our graph as well. It also asks, what feature does the graph of f of x have at x equals 2? So if we go to our graph and look at x equals +2, we have a vertical asymptote there, and that's because this -2 here shifted everything to the right. So our last question is, the graph of f of x has what horizontal asymptote? And just looking at the graph, we can see that our horizontal asymptote is y equals 0, because both the limit as x approaches positive and negative infinity of our function is both going to be y equal to 0. And that is it for 3a.